The textbook has this static picture that shows you, trying to show you the concept of what a confidence interval is, what a z-interval is doing. I made this GeoGebra applet and I have a link to it in my notes. So in this video I'm going to just try to show you, it's a demonstration of what the confidence interval is doing to try to make sure you understand what's going on here. So I've built this GeoGebra applet. You can change the mean and the standard deviation in your sample size and it'll create the normal distribution based on that. So it's centered at mu, and then it's going to compute the confidence intervals, and you can change the confidence level as well. Sorry, let me resize there a little bit. You have to give it the confidence level for the confidence intervals you're going to compute. I have it at 90% right now. Let's change it to 95%. It'll compute the z star and the margin of error that you would need for that. And then, so this picture, these vertical lines are going up at mu plus or minus the margin of error. And then if I click, it's going to take a random sample and create a sample mean and do the sample mean plus or minus the margin of error. And as long as the sample mean falls between these two lines, the mean itself will be captured in the confidence interval. So I can take, so if I do 95%, if I take 20 samples, I would expect 95% of them to capture the mean and one of them to not. Now that's a probability, which means that may not be exactly what happens, but let's see. I've done 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that time we got 1, 2, 3 of them actually that didn't. So I took confidence. So what I did, every time I click the button, GeoGebra is taking a random sample from this normal distribution that I have set up. There's a built-in way it can do that. And it's creating the confidence interval. So graphically in the picture, if this dark green, if the sample mean is within mu plus or minus the margin of error, then mu is in the confidence interval. So we wound up with 3 of them, which was a little high for that. But again, it's a probability. Okay? It's if I did it a large number of times, and I only did it 20 times. Let me reset it and try it again with new ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That time it did it exactly by what the theory would say. There's 1 that's not and 19 that are in there. So 95% of the confidence intervals that I created captured the mean and 1 of them didn't. Again, it's a probability. You do it like a million times and you would expect it to be really close to 95% of them that capture it. If you do it a small number of times, you could have some variability there. But the whole point of this picture, whether you understand every bit of it or not, is that when I click the button, what it's doing is creating a sample mean and then creating the confidence interval by having the z star and using that to get the margin of error. And in the picture, as long as this line is representing, the line segments are all representing my confidence intervals, and you can see, and I built the vertical lines because whenever, I have this one down here that shows as well, as long as my sample mean is between those 2 vertical lines, my confidence interval is going to overlap and capture mu. The second that the sample mean goes beyond that line, the edge of my confidence interval has gone past mu and I no longer capture mu. I've got this one down here. You can slide to see that concept and it turns red when it fails to capture the mean. So for the vertical bars here, every time the sample mean falls between those, the confidence interval is capturing the population mean somewhere in the interval. And so the concept is when you do it over and over and over and over, a lot of them are going to capture the actual population mean, some of them won't, and theoretically it should capture it C% of the time.